Hello, 8th graders. I'm going to answer with you the assignment that you have to do, the course book questions, pages 17 and 20 from Unit 2, Describing Motion. So let's start with question 1. If you measure the distance traveled by a snail in inches and the time it took in minutes, what would be the units of its speed? So in this situation, we are measuring the distance. Let's look at the formula at first. Speed equals distance divided by time. So we are measuring distance in inches and time in minutes. So our final answer, speed, will be in inches per minutes. Question 2. Which of the following could not be a unit of speed? So the unit of speed should remind you that you divide distance by time. I'm going to look at each unit here given and see if they are dividing distance by time. Kilometer per hour, yes, they are dividing distance by time. Seconds per meters, this could not be a unit for speed because here we are dividing time by distance. Meters per hour, this could be a speed unit. Meters per second, and this could be a speed unit. Meters seconds, this means here that we are multiplying distance by time, so this too could not be a speed unit. So the units that could not be speed units are seconds per meters and meters seconds. Question 3. Information about 3 cars traveling on a motorway is shown in the table. So we have 3 cars, A, B, and C. Car A is traveling 80 kilometers in 50 minutes, B 72 kilometers in also 50 minutes, and C 85 kilometers in 50 minutes. So each vehicle is traveling a different distance, but they are all spending the same time, which is 50 minutes. A. Which car is moving fastest? So the fastest car should be the one traveling bigger distance at the same time. In this case, it's car C. Which car is moving slowest? The car that's moving the slowest would be the car that's traveling the least distance at the same time, 50 minutes. So it would be car B. Question 4, page 20. An aircraft travels 1,000 meters in 4 seconds. What is its speed? So the distance it's traveling is 1,000 meters. Time, 4 seconds. What's speed? A very straightforward question. Speed equals distance divided by time. 1,000 meters divided by 4 seconds equals 250 meters per second. Question 5. A car travels 150 kilometers in 2 hours. What's its speed? Show the correct units. So the distance is 150 kilometers, time 2 hours. Speed would be calculated using the units kilometers and hours, and the final answer would be kilometers per hour. So speed equals distance divided by time, 150 kilometers divided by 2 hours equals 75 kilometers per hour. Question 6. An interplanetary spacecraft is moving at 20,000 meters per second. How far will it travel in one day? Give your answers in kilometers. So, the speed of the spacecraft is 20,000 meters per second. We need to know the distance it's going to travel in one day. So now, according to the speed we have, the unit for time here is seconds. So we need to convert the time from one day to seconds. So one day is 24 hours. From hours to minutes, we multiply by 60. So 24 hours are 1,440 minutes. From minutes to seconds, we need to multiply again by 60. And the answer would be 86,400 seconds. Remember that you can use a calculator to do these calculations. If you want to convert from 24 hours directly to seconds, we would multiply by 3,600, which are 60 multiplied by 60. So now we have our time in seconds. We're going to use the distance formula. Distance, after we rearrange the speed of formula, of course, equals speed multiplied by time. Speed is 20,000 meters per second multiplied by 86,400 seconds. Eliminate second with second. And our answer is 1,728,000,000 seconds. Meters. So this is the distance it's traveling in one day. 1,728,000,000 meters. To convert this to kilometers, we have to divide this number by 1,000. So the final answer is 1,728,000 kilometers, the distance traveled by the spacecraft in one day. Question 7. How long will it take a coach traveling at 90 kilometers per hour to travel 300 kilometers along a highway? So this coach is traveling at 90 kilometers per hour, the speed. It's traveling for 300 kilometers, the distance. We need to know how long will this take, the time. So, time equals distance divided by speed equals 300 kilometers divided by 90 kilometers per hour. The answer is 3.33 hours. How much is this in hours and minutes? So this is 3 hours and 0.33 hours. 3 hours plus 0.33 hours. We need to convert this part of an hour to minutes. 2 minutes by multiplying by 60. This part here will equal to 19.8 minutes. So 3 hours, 19.8 minutes, which is about 3 hours, 20 minutes. And the last question, question 8. Sketch a distance time graph to show this. The car traveled along the road at a steady speed. It stopped suddenly for a few seconds, then it continued its journey at a slower speed than before. So remember, when you're asked to sketch This doesn't mean that you need to do any drawing. Sketching means that you need to do a proper drawing using a ruler. So this is a journey. We need to know how many sections this journey is formed of. The car traveled along the road at a steady speed. So this is the first section. Any car starts motion from 0 distance, 0 time. So the first part of this journey, before we start drawing, of course, we need to label our graph. So this is time, and the time mentioned in the story is seconds. And this is distance in meters. Okay, so it started traveling at a steady speed. Remember that we draw a steady speed as a straight line, and the line must be sloping upwards. We start at the 0. We draw the first section as a steady speed, a straight line sloping upwards. It stopped suddenly for a few seconds. When an object stops on a distance time graph, the distance now is not changing. So the distance will continue to be the same, whereas the time is still passing because the bus or the coach has stopped. So when the bus stops, the line would become flat and horizontal because it's showing a stationary situation. Then it continued its journey at a slower speed than before. Now it continues at another steady speed, but it's slower than the beginning of the journey. So to differentiate between these two sections, we need to change the steepness of the line at the end of the journey. If it's slower, so it needs to become less steep than this. Of course, the steepness of the line is determined by how close it is to the y-axis, meaning that more distance is traveled in shorter time. Now the last section here is steady speed, but it's slower than before, so it needs to be less steep than this line. We decrease the steepness of the line. Thank you, 8th graders. I hope that you find this video clear. If you have any questions, please don't hesitate to ask me.